Welcome to the seventh tutorial in this series where we're using a mesh to create our Minecraft terrain, and we're using Petaramlan's Ursina module so that in Python we can create something that looks a little bit like Minecraft. So here we are, tutorial 7, I believe, and it's looking very Christmassy on there because the last video I made was just before Christmas, and I thought I'd make lots of videos over Christmas, but I had no time. So, but here we are, Happy New Year in 2022. Hopefully everything's going okay with yourself. And right, what we're going to do in this video is the following. We're going to build, or I've written the code for how to build stuff. So I'm just going to show you how to do that. So there we go. We can build things like this, and we can interact with the stuff that we've built, and we can mine the stuff that we've built, and we can rebuild. There we go. Right. Also, what I've done is what we're going to do is we're going to improve the the tool that we're using to mine and to build. So I call it like the highlighter tool, which is a little different to how Minecraft does things, but I like this version at the moment. So a tiny little bug fix, really, to make sure that what we're looking at gets highlighted and things feel a lot smoother. So I can do mining a lot quicker like this. The other thing we've got to fix is the snow, so that we can turn it off and on a lot more easily, so preparing for other kinds of weather like rain, things like that. Basically switching off the snow because we're coming out of Christmas now. Although obviously when you're watching this, it might be in the middle of the summer, of course. And the final thing that we want to do is thank you to someone called Les Wright over in America. Thank you very much. Who pointed out a brilliant improvement to the dictionary code, so that we don't have to build up those fiddly strings to find where specific blocks are, but we can just use a tuple, or a tuple, you can pronounce it. A lot more efficient. So that's fantastic, because that is a key part of how we're making things work. Right, let's get going. So we're going to start with, with me pressing the wrong button down here. Okay, there we go. What we're going to do is, sort out our Snowflake. So what I've got to do is open the main module. Remember that our project is organized into lots of different modules. So the main module, traditionally that is like your main program. That's why it's called main. And you want to try and keep this as short as possible. Where are we? Oh God, we're under 100 lines. But we're getting a little large there. So maybe some of this stuff where we're moving the character around might need to go in its own module later on. Anyway, I'm getting distracted. What we want to be able to do is, where I'm saying on line 18, I'm creating a list of flakes, and then I'm running this for loop to generate 512 flakes. Then I'm adding those flakes to the list, so that later on in the update loop, which iterates, giving us like 60 frames per second, hopefully. And then inside that loop, I'm then saying, or that main update loop, I'm then saying iterate over all 512 flakes and work their physics, do their physics, i.e. fall to the ground. What I want to do is, and what we're going to do, is place that in the flake module itself, over here, so that it all belongs together. It belongs together so that it all stays together where it belongs. So I've already done that, so I just need to kind of, on the flake module itself, I just need to walk us through, and hopefully I've done this. I've put 3 asterisks where we need to add code, or you need to add code, or you can just download this from my GitHub. Link is in the description. So the first thing we do is, before the initializing function, which we don't change, above that we're going to add 2 things, which is quite new to our Python code, but very useful. but a little bit more sophisticated, although easy to do. I'm adding up here a variable that belongs to the flake class. Notice it's a variable that doesn't have this dot or self dot, because although it belongs to the class, this variable, it won't belong to every single instance of that class. It's not going to belong to every single snowflake. And what is this variable? This variable, sub, will just store the subject, the player, from our game, because we need to know the player's position so that when the player moves a long distance across the terrain, the snow cloud kind of follows where the player has gone, where the subject has gone. So every flake, in a sense, needs to know where the subject is, the player is. But if we had a variable, like I could do this on the flake, on each individual flake, I could say this dot sub equals, and then store the player's changing position there. But that means every time the player changes position, we have to tell every single flake where the player is. What's a lot more efficient than that is to just store the player's position once inside the class, so not for every single flake, but so that later on, where are we? In physics, which we've already written. So this is a member function of the flake class. We then say subject position, and I've used that here because this code down here has already been written, so I didn't want to change it. So up here, I'm just populating sub position, that variable, with this new class variable. So here's where sub appears. Now to get hold of this variable sub, where we're going to store later on the subject's position, you just have to write the name of the class. Although we're inside that class, we need to know that this variable is that class variable. So all we do is write the name of the class, dot sub, and then dot position. Now I can write dot position because sub is going to be our subject passed in to this class, and I'm going to show you how to do that in a moment. So that's the first little change done. I can delete those asterisks. Then a little further down here, there was a little bug. I think I'd put in here plus equals z. So that's what was happening when, I think I remember this just before Christmas, we were wandering around and the snow was like going off away from us, and it was along the z-axis, and it was because I put plus equals instead of just equals. And what we're doing here, just to make that clear, this is after the flakes respawn randomly around the player. So it wants to just be the player's position plus a random amount. Oh, also what I've changed is, I think before this was like 40 away from the player minus 20, i.e. 20 away from the player on either direction. So I'm just changing this to 20 minus 10. And I've also very badly repeated that code up here. So in the initializing function, I've also got 20 minus 10 instead of 40 minus 10. That's if you're writing this yourself from scratch, as it were. You'll have to change that. Okay. Right, so we fixed the bug for the repositioning of the snowflakes. Right, so I can delete these asterisks, although I've got one more thing to write up here, just 3 very short lines. And that's a decorator. I don't think we've used that before in Python. All it is, it's like a keyword to say that this function, set sub, so this is where we're going to set the subject, or rather set this, or populate this class variable with the subject's position. Actually, it's not the subject position, it's the whole subject that we're going to pass in here. I'll show you that later on. I wish I'd shown you that first, else this seems a little bit complicated, me explaining it this way around. Anyway, this static method means that if it's static, it's not created for every single instance of this class, so every single snowflake. So static method just means just make one of these functions that belongs to this class. Right, and all we're doing is we want to pass in the subject entity, and then what we do here is store whatever subject entity we pass in there into our flake.sub, which is this variable up here. So flake.sub gets hold of the subject that way. How do we get that in there? Finally come to this last bit. Oh, remind me, I don't know how you're going to do that, but I'm going to remind myself to come back to the update function there in a second. Right, we just have to write another class within our flake class. And I've called this Snowfall. So what this is like what should I call it? Like a controller, like a control system for our snowflakes. So we're just going to have one class that looks after all of the snowflakes. So just like the other class, we write class Snowfall beginning with a capital S. So just like our flake, we've got class flake, capital F. And then def dunder, so that's double underscore init. This, because we need a reference to point to an instance of this class, an object instance. And then we're going to take, when we initialize this back in the main module, that's where we're going to pass in the subject. And let me go and show you that, or rather, I guess we need to do that. So in main, I don't want to import flake anymore. I'm just going to import Snowfall. There we go. So I'm just going to import this class. And now, because this is like the control system for all the snowflakes, my main module doesn't have to worry about all of this. The Snowfall class takes care of that. Okay. Which is nice. It's like a nice daddy. It's being a nice daddy to all the snowflakes. What do we do next? Okay. So this flakes equals a list, and this code should look very familiar. Basically, what Snowfall is now doing is doing this for us. So inside our main module, we're no longer going to build a list and iterate over how many snowflakes we want and append them to the list. We don't need to do that now. We're going to take care of that in the flake module. Okay, but what we do need to do is say, now what did I do in my prepared code? What did I call it? I called it Snowfall. Okay, I'll do the same. So I am going to say, so up here, I'm back in main. So up at the top of our module, we import the modules that we need, of course. Then we create our Ursina app from the module, and then we sort out like window colors and the sky, create our subject, and create our terrain object. So up here is where we're creating our basic objects and things. So this is where I need to, or this is a good place to create our like weather systems. So I'm going to call this Snowfall, all lowercase because it's just a variable, equals, and now because from flake module I'm importing the Snowfall class, I can say that is a Snowfall object. And what I'm going to do in here is now pass in our subject. There we go. So that means, and this will make a lot more sense now, in flake we pass in the subject to this, that gets stored in this parameter, underscore subref. I've just put an underscore because that's my habit. You don't have to use an underscore there at all. But basically, in the initializer function then, we get hold of the subject and we use our set sub function, which is which is a static method on our flake class, and that takes the subject entity. And let's just go and watch this. There it is. There's a static method. So this is part of the flake class. it takes our subject entity, and all it's doing is storing it in the flake.sub variable. Here it is. All it's doing is storing it in there. And the reason why it stores it in there is because when we get down to our physics on our snowflakes, we've changed this to the subject position, which we use down here, which is the same code as it was in the last video. We're just saying before we get down here, subposition pos equals flake dot sub dot position. There we go. So every single snowflake doesn't have that stored, but it can reference it because it's stored once up here within the class. Okay, I don't have to say anything else about this flake static method stuff. That's done with, and that's the most complicated thing in this video, but really useful, static methods and things. It's basically when lots of instances or objects belonging to a class need some data that's exactly the same data. So you don't have to repeat it over all of the instances. You just want to keep it in like a static area of your class. Okay, so that's done. So there we go, we set that. And then we're just iterating over our snowflakes. I've said 128 now, just to try to improve the performance there. So instead of 512, we're going for 128 flakes. And that's why I changed this random positioning of the flakes. So they're only 10 away from us, just to try to give a sense of more density. So the snowfall looks as good as it did before. And then we're saying, the flake begins at the subref dot position. So beforehand, in the main module, we were saying the snowflake should start at the subject's position and then move away and things like that. Right, that's done. I can take away these asterisks. Is that the plural of asterisks? Astereses? I don't know. Astereses sounds pretty good. Right. Any more asterisks? Oh yes, there was. Good job I put them here. Okay. I just read, just incidentally, looking at some Ursina code, that if you've inherited from the entity class, which we have done to build our flake class, then you can use an update function. And if you do, that update function will be called automatically every time your application is updating. So that means, crucially for us, we don't need to do anything to the flakes in the main update function. So this is back in the main module. What's really satisfying now is that we can clean up this code. I can delete that horrible stuff to do with flakes. That shouldn't be in our main module. That should just be taken care of by our snowfall. Notice we've just written one line now in our main module. Snowfall equals snowfall, passing the subject, and now that's completely self-contained. That's what a module should be able to do. I say that, we haven't got it working yet. So I've written this new function. So this is inside the flake class, and it's just a normal member function, class function. So def update, I've just written it above the physics function. And remember, although we're not actually passing any argument in, we do need the this or the self parameter, because every member function needs to be able to refer to the particular instance it is operating over. Okay, and then all it does is call the physics function of this snowflake, this particular instance. That's it. Easy as that. So that was a nice one to write. So that's just taking care of its own update. Right. I think that means, let's just go back to our main module. All we've had to change up here then is from flake import snowfall. So instead of the flake, we've imported snowfall, which will take care of the flakes. Then we've deleted all the stuff that creates the flakes and the stuff from the update loop. How many lines have we got now? 78. That's pretty good. Right. So if I run main now, take some tea. Oh wow, it's running. Oh yeah, we've got our footstep noises. I think I did that last time as well. And our snowflakes are still being updated, even though that's not happening in the main update loop. That's happening in the module loop. So again, if you're talking about an entity, it's got its own update function that you can call. And if you built your own class like we have, our flake class, inheriting from the entity, Ursina's entity object, then you can call that, you can just use that function, which will automatically be called, so you don't have to mess up your main update function. Okay, so next thing we should go and do the building. Now, as I'm looking around, I notice like my highlighting is off slightly, so that needs to be sorted out later on. And at the moment, I can click very fast, and we are mining, which is lovely. Okay, so I'm just trying to decide. Less right improved our code for us. I've got an idea. Can I? Oh, I deleted the wrong one. Anyway, right. Maybe I can bring this up. I'm looking at partial derivatives. Let's have a look at. Here it is. So here we are. Less right. Thank you very much for showing me this. So, look how clear this is as well. This is exactly the kind of thing that you want. By the way, where am I looking at? I'm looking in where you go and download my code. So if you click on the Issues tab, you can put in requests there, or if you notice bugs or if you've got any questions or anything, you can put it up here as well. So where in my code we're using the dictionary to go and check a certain position on the terrain, and we do things like when we're mining, we want to know, should we generate some walls around it to create the illusion of mining through loads of layers in the earth. We don't want to spawn a wall if there's already some terrain there, so we need to go and check on the dictionary if there is terrain there. So we do that by building a key, and a key at the moment I'm building up out of the position, so the X, Z and Y, or the X, Y and Z position of our perspective block or whatever. And then what I'm doing is concatenating or adding together parts of that string. So it'll read something like X is at that position, Y is at that position, and Z is at that position. So then that key will be unique to that position on the terrain, and then I can know if it's got a T there standing for terrain, or a G for gap, or whatever else. Now, what Les has pointed out is that, and look how much shorter and nicer this is and cleaner, we're still flooring our X, Z and Y, or X, Y and Z components of that key, because we don't want 4.2, we just want 4, or we want -4. So we want integers. So we're still using floor, but when we're building the key down here, notice the double brackets. We're just using a tuple or a tuple. So we can just bang in X, Y and Z like that, and that will do exactly the same thing as our string key, which is a lot messier. Now this is a lot faster because we're not having to convert things from floored integers into strings and then concatenate and things like that. We can just bang those in a tuple, and a tuple is just an ordered, immutable list, really, or I should say collection. It's like a list. There we go. And in Python, all you have to do is wrap something in parentheses, and as long as you've got at least 2 of them in there, separated by a comma, that will become a tuple, or be recognized as a tuple. Or if you've only got one item in there, it's weird, you just leave a comma after that item without another item after it, if you just want a single thing in your tuples. Anyway, so thank you again, Mr. Wright. That was brilliant. Let's go and sort that out. So it's not a big job. We just need to refactor things. So we need to do this in main, the mesh terrain module, and the mining module. So that's all we have to do. So we'll do all this now before we do the building, because the building will use a dictionary, so we might as well get ready. So here we go. I'm in the main module, and I've gone down to line 65 at the moment. So this just needs to be a tuple, and I'm just going to remember we've got y plus I right there. So I'll delete everything in there, and then put my tuple brackets inside, and then I just need x, comma, y plus I, comma, z. Oh, accidentally auto-completed to zip. Save that, so that's done. Although notice just above that, where we're creating our x, z, and y, or storing our positions in x, z, and y, we can leave the floor, but we don't want to convert that to a string. We don't need to, because our key is now a tuple. Also, I'm going to do what Less Right did. Clearly a much better programmer than I am. He's used the single quotes in his Python, so I'm going to start trying to do that as well. Okay, so now let's take away the string converter. I don't know what to call that. Is it like implicit something? Anyway, there we go. So we've got x, just needs the floored, so just an integer value for where our subject is. Okay, so this code down here was that stuff that we need to refactor and put somewhere else in its own like module later on. Not this video, don't worry. Sorry, this was to do with not moving the player, but seeing where the player is and then deciding whether we need to move the player up or down. So this is like our efficient collision detection at the moment. Do we do anything else? No, that's done. So we've done our Less Right conversion tuple dictionary for main. Right, so let's open where is it? Mesh terrain. Can I open two things at once? And the mining system. Whoops. Open. Look at me opening two modules at once. Are you not entertained? Right. Mesh terrain. So let's look down here, and anything with a string around it to do with a dictionary. Here's where we create our dictionaries. We need to remove those stringy things. Here we go. So we can clean up all of this. So yeah, we just need to take away the string preceding things. And then when we've got plus, basically, we just need a comma. And then at the start of that, we need a bracket. We're going to put things inside of a tuple. And I guess we don't need the trailing bracket there. Don't need the trailing bracket there. We probably do need the trailing bracket there. Yes, because that bracket matches with our tuple. Okay, so that bit's done. There we go. Very good. Generate block. Here we go again. So record terrain in dictionary. Again, I can leave that bracket there because the whole thing needs to be wrapped in brackets to signal that it's a tuple, as well as having, wherever we've got plus operators, addition operators, to concatenate the string, we just need an x, y, and z separated by commas. So I just need to take away those two brackets, don't I? And then these prefixed string things. So again, we've just got a floored x, floored y, floored z, all wrapped in brackets there. I guess, can I fit that onto one line now? To make our module shorter, yes we can. Oh, Less Right, thank you so much for this. Oh, and in honour of Less Right, let's put single quotes. There we go. Good. Here we are again. Can I just copy that now? No, I want to be very careful because these different dictionary references, or where I'm building different keys, I'm doing slightly different things. Like I've got floored y here, but I've got floored y plus 1 here. So it's best just to work with each individual one without trying to cut corners. Anyway, I can leave the first bracket on, plus I can change to a comma, take out that bracket, that one there. That looks good to me. Again, let's try and get this onto one line. So we're just squashing up our, and that reads just as well as separating it into consecutive lines, I think. There we go. Again, a single quote there. I'm kind of a fan of doing this as well. I don't know. I guess I should do this up here. Is that more Pythonic to do that? I don't know. That does look nice. I like that. Anyway, here's another one. We're down to line 83 now. So I leave the first bracket on, don't I? Convert the addition operator to a comma, take out that other bracket, delete that first bracket all the way up to there, leave this final bracket there, delete the first bracket there, done. Let's go down. Oh, look, here's where we're using our texture atlas. Can leave all of that. And this might be the last one. Yep, down at the bottom. What function are we in? Oh, this is where we're generating the terrain. Okay. So nothing is made into a string. Good. So it's all in here. So I just got to be careful. Oh yes, I leave that first bracket to make the tuple, which matches with that last one. Where I see a plus operator, change those two commas, and I can delete that bracket. This preceding stuff, take that bracket away. This preceding stuff, leave that bracket because it's the final one. Because yeah, we're hugging everything there. Notice again, it was good that we did each individual one because we're doing weird things like x plus k and z plus j in here. Because that's where we're going around a grid. Okay, that's done there. Right. That's all done. Okay, this is not taking long. And then finally, let's go to our mining system. And we've got some X, Y's, and Z's here. Here we go. So, within the highlighter. So this is something we want to improve as well, in terms of where it's like really direct, where you're directing your gaze. Which I'll fix after. No, I'll do the building first, and then we can fix exactly where we're looking. Okay, so we want to. Oh, it looks like we can just. Oh, they're already. So X, Y, and Z are already floored up there. So we don't need to floor them down here. So we do just need an X, but we do need a first. Are they just X, Y, and Z? Yeah, okay. So let's make this really clear. We can just say tuple X, Y, Z like that. And then use the less right single quote marks. Brilliant. Done. That's nice. Okay, this one's slightly different. So let's treat it. And it's floored within the construction of the key right here. So I'll leave the first bracket on because it's a tuple. Take that bracket off, comma where the plus is, take that bracket off, take that preceding stuff away, that preceding stuff away, and we should be done. Except for putting it onto one line. Yes, it fits onto one line, that's very pleasing. Especially if we just Pythonic up this stuff. Okay, lovely, good. Right, was there an opportunity up here to put stuff onto a line? I did it already. Oh, look at this stuff. Right, let's go and do this. So, leave the first bracket. Where there's a plus sign, delete, comma, plus sign, delete, delete, comma, delete the preceding stuff, and then, oh, accidentally took that comma away. Yes. I've never really done this much refactoring before. I'm finding it quite satisfying going through this. This is the last little bit we need to do, but apologies if this isn't too entertaining. I don't know how hard this is for you guys to kind of follow. If you're writing along, and by the way, well done indeed. I find it amazing if you're actually writing all this up yourself, following along. Let me know if you are. I think that needs special congratulations. But this is a little fiddly with all the brackets and things, but I think once you understand the principle of what I'm doing, it's fairly straightforward. Okay, there we go. And now we're under 40 lines in our mining system. Isn't that great? Okay, so now we'll try and run it, and if it doesn't run, this is going to be impossible to fix, but let's have a look. Okay, we've got a terrain appearing. Oh my goodness. And we can walk. Brilliant. Can we mine? Yes, we can. Can we build? No, because we haven't written that code. Lovely, but now our terrain dictionaries will be much more efficient. And in fact, let's just go and improve performance. In mesh terrain, we can set our subwidth. So if we decrease that by 4, so that's how many cubes, how many blocks are being produced each update loop. And now you can see we've just doubled our frame rate, which is a lot nicer, clearly. And it's very smooth. Even though I'm recording, we've got snow falling, we're generating our terrain right now, and we're even mining. I wouldn't say silky smooth, but incredibly smooth. You know, it's not jolty or anything like that, but it's not, you know, it's not 60 frames per second. But anyway, it's mainly our snow, which is an awful hack job, slowing us down. Lovely. Right. Talking of which, if you want now, you know, it's Christmas is over, so if we want to turn off our snow, we can just comment that line, and then we shouldn't create our snowfall like controller. So yeah, skies are clear, and now I've just registered 60 frames per second, 74, 54. So we're getting here and there more silkier performance. Okay, and that's very satisfying now. To turn on or off the snow is very easy for testing, and then later on when we want to build an actual weather kind of system, we want to be able to do that. We want to be able to switch it on and off very easily. So that bodes well for our development. Okay, so the main thing we want to do now is get our building working. So the good news is, having developed mining where we're like spawning blocks, and indeed where we first, you know, generate our terrain, where we're making blocks, we've done all the work. We've done all the work for generating our terrain. Generating blocks. So building is relatively simple, or all we're going to be doing is copying and pasting a little bit of code. So I suppose where we need to begin is in our mining system, in our mesh terrain, where I just was. At the moment, in the input function, we've got, if we're pressing the left mouse, then we do some mining. So it makes sense here to do some building. I'm very happy about this. Okay, So first thing we might say is if our BTE, which stands for build tool entity, that just means the yellow entity that's doing the highlighting, it just sits over the top with some transparency of whatever block you're kind of looking at. And if it's visible, that means we've selected, or we're looking at a part of the train. If we're just looking at the sky, we make the BTE block invisible, so nothing's highlighted. If we're looking at a block, then it's visible and it's highlighting. In other words, we can say whether it's possible to mine or not. If this thing is visible, then we could build on top of this place, possibly. So if it's visible, we don't need to say equals true, because we could just write BTE visible. I'll write that though, just to make the code very clear. If it's visible, then we can go and do the building stuff. Right, now I'm going for speed's sake, I'm just going to have a look at my prepared code. Here we are, mesh terrain. I want to look in input. And here are my asterisks, friends. So B site, so like build site equals, and it looks like I've written a new function, probably on a new module, check build. So it's going to say, basically, check, can we build somewhere? If we can, it's going to return in here a position. It looks like we're then just going to call generate block, which we've already written. And all we need to pass into generate block is an X, Y, and a Z. In other words, we need to tell generate block, where do you want to generate a block? And it does the rest for us. Looks like we're going to generate that block on subset 0. So the first subset that we've got, we're going to use its vertices. And then later on, we're going to say subset 0, generate your module. So we can actually see the new vertices, the new block that we've built there. And we can pass in block type, soil, or whatever you want. And we'll develop that later on. When we select different block types that you want to build with, this is where you can pass that in. Okay. Right. So what we need to go and do is write a check build function in a new module. So we're going to pass in the key, so to check that we've... Actually, could we do that out here? We can do that out here. Yeah. Let's copy that. So in our... So let's improve my prepared code. So if right mouse up and BTE is visible, then we're going to do some building. I'll just write pass here at the moment, out of habit. Okay. That just means if we try and run this, this will still work. It won't create an error. Because if you've done a colon at the end of an if statement, or a function definition, or the start of a loop, and you don't have anything here, you get like an error, and that's why this has gone red. So I'm just going to leave pass there. So that means if you're not ready to write your code yet, but you still want to run what you had before, then that will be okay. Okay, what am I doing? Right, yes, we want to create a new module. And so whenever you create a new module that's used in this project, all you have to do is save it in the project folder. Again, if you're not writing it yourself, you can just download my project folder from GitHub. I'm using Visual Studio Code, so I just got to select that. I'm using Python, and I'm going to call this building system, because I called the mining system module. So building underscore system save, and let's just write a comment at the top there so we know what this is. Our building system 2022. Happy New Year. So that'd be nice. When I look back at this, or we look back at this in the future, or maybe you're looking at it in the future, welcome, future traveller. When we're looking at this, it says Happy New Year. That'll just remind us of these nice, these nice times. Okay, what am I talking about? We're in building system. So in here, we need we're not going to use a class. We're just going to use an ordinary function. Def check build. We don't need to pass in a key, but I do want. What do I want to pass in there? Not mining system. Mesh terrain. Oh, I want my prepared code. I want to pass in there. Oh yeah, the BTE position. So where am I looking at with the highlighter and the terrain dictionary? Yes, we want to know whether there is something already on top of that position. If there is, we don't want to be able to build there. So building system, we need what should I call it? B site for building site, and then we need it was just there terrain dictionary. I'll call that underscore terrain dictionary. Sometimes I use underscores just to remind me that these are parameters, like temporary parameters belonging to this function, and not like the official TD. I could use TD, but I've got another TD elsewhere, so it helps me keep track of what belongs to this module and what doesn't. Okay, so let's now just go and have a look at my prepared building system. So we don't need to bother about the right mouse key. And I've called my BTE up there. Okay, so I want to add, oh yeah, minus 0.5 from the build tool entity's position. I'll explain that in a moment. Let me just go and do that. So I want to say bsite equal or plus equals vector 3, nothing to the x dimension. We want to take off half a unit, so lower it by half, this block, and then nothing on the z direction. Vector 3 doesn't exist here, so I just, in this module, have to, from Ursina, import vec3 at the top. Now, the reason why we're doing this is because our block model I made, and it's off by half a measure compared to the cubes that are generated by Ursina. So where the build tool entity is sitting in reality is always half a measure off. So we just have to take that off here. So I might just make the comment adjust build site since build tool entity or BTE offset. There we go. So we know what's going on there, because this in 3 years' time would be completely random. We're like, why are we adjusting that by half a measure? It doesn't make any sense, because like Minecraft, all of our terrain is at whole number positions, like 1, 2, 3, not 4.5 or anything like that. Anyway, the build tool entity, its actual position is a whole number, but the model, if you like, is off by half. That's the best way to think of it. Anyway, we've now adjusted that. So what's the next thing to do? We're going to floor each of its components of that vector 3 is x, y, and z. And I'm also going to store it in x, y, and z here, just so it's more convenient, so I don't have to write beppy.x or buildsite.x or anything like that. Okay, so let's just write a comment as we're going. Store in convenient variables and floor. Okay, so x equals bsite.x and floor. Floor doesn't exist, but again, that's also included in Ursina. There we go. X, Y, and Z. Good. Now what am I doing? Right. Oh, I've actually written a comment in my preparation. First, check there isn't already terrain there. So now we're using the terrain dictionary. So I'm getting that position. Oh, look. I need to add 1 to the Y component. Because the build site is actually one above the block we're looking at. Anyway, let's read the whole thing. So I'm using the dictionary. I'm using a new tuple. Thank you again, Mr. Less Right. Using that tuple to build a key, and if it doesn't equal a G, which means gap. So if it's not a gap and it's not none, I'm going to print this message, error message. There must be terrain there. If there's a gap there, it's okay to build, or it would be okay to build. If there's nothing there, it's okay to build. So I need to say there must be something there. So I'll just print to the console there's something there and then return none. So that's from check build. So basically, if check build returns nothing, it means you can't build there, so don't build anything there. If we can build there, it's returning the build site location, which I've got in X, Y, and Z. Okay, I think I can remember all this now. Let's look if I can. Okay, right, so firstly, this needs to be X, Y, and Z. Oh, well done if you spotted that. And I want to plus 1 here. Store and configure a floor. Also, increment Y by 1 since building above. There we go. Good. So yes, make sure no block here already. ... So if td get, now I can. Oh, this is gonna be so nice. X, Y, Z. Oh, lovely. If that doesn't equal gap and can I fit this all on one line? That would be amazing. And td get doesn't equal. It's bad that I've kind of done that twice. Anyway, I can get it all onto one line if I do it this horrible way. Doesn't equal none. Then print can't build here. Sorry. Oh, I need to do like an escape character thing. I don't know how to do that. Oh, wait a minute. Here's where I can use the quotes, right? Yeah, there we go. That works. Okay. Print can't build here, and then we want to return none. Oh, so I don't need to do an else here really, because if we can't build here, we'll return. So if I've got here, we can build. Let's just write that so we can easily read this code. If we're here, we can build. Yes. Right. So, or can we? Or can we? There's something else that I've forgotten, isn't there? Oh, right, that all that else was to do with the right mouse up, so that's fine. So I can just return the build site, which is free to build in. Okay. So return XYZ. So let's just make a new vector3 out of X, Y, Z. That should be fine, shouldn't it? Like that. Okay, good. Right, 20 lines. A nice, that's a cute little module so far. Okay, not that it works yet or anything. Let's see. Where are we? We're in the mesh terrain and we're in the input function. And we're saying if we press the right mouse key and our BTE is visible, we want to put build above there, we want to get a position. So I'll call that the same thing, B site for build site or potential build site equals check. Now, why isn't check build coming up? That's because I haven't imported the building system module. So I have to import this. Because I'm in mesh terrain, that's the module that needs to import it. So from building system, import all, import everything. It's not detecting it. Have I left a horrible mistake in there? I don't think so. Oh, it's probably because I haven't finished something down here. Yeah. So build site now equals, can I go to check? Oh, is it called build check? Is that why? No, what's going on? From building system. Check build. What have I done wrong here? Let me just have a look at my prepared building system. From Ursina, vec3 floor, check build. From building system, import everything. That's my prepare code. So in my mesh terrain, from building system, import everything. It must just be a spelling mistake. What have I done? From, it's coming up with building system prep, but not my building system. Let's just forge ahead. Anyway, build site equals check build. And we want to pass in there the BTE dot position, not the whole entity, but just the vector3, and then we want to get hold of this dot TD. That's a terrain dictionary. I'm very confused as to why I'm having any kind of problem with this. Again, I wish I had like live comments. You've probably spotted what I've done, and I can't see it myself. Mesh terrain, import mesh terrain. Mesh terrain. Let's just go to save as. Let's just have a look at a project. Maybe I saved it on the desktop or something. No, it's right there. Building system prep. I haven't got any conflicts between the other preparation code. Try replacing it. And then if I go to mesh terrain, still looks like it can't find it. Anyway, maybe if I just try running it, let's have a look. That might indicate that it has found the. There would have been something wrong with the import. So I can still mine. What if I right click? Ah, good. So obviously nothing's been built yet because we're just like checking whether we can build there, but it's not crashing the program. That's the worry. Where's our mining? Not mining system. Mesh terrain. Still doesn't like it. It's pretending it doesn't like it. Anyway, it seems to be fine. A little glitch there. Again, in the comments, if you know what's going on there, let me know if I don't find out later on. Okay. So, then I presume we're going to say if B site is none, then, oh, wait a minute, we'll say if doesn't equal none, then we'll do some building. Is that what I did in my prepared code? We've just gone over an hour building system, which isn't too bad because we are accomplishing hopefully quite a lot. Not my building system, sorry. We want to go in mesh terrain, prepared code. Yes, here it is. Yeah, does not equal none, then generate block out of the floored positions. Okay, right. Oh, that's exciting. That's basically the final, well, the main thing, not the final thing, but the main thing. Then there's just two other little bits, and then our building system should be in place. So, yeah, we can this dot gen block. So we need floored bsite.x, and now I just copy these. So these are just arguments we're passing in to the generate block function. So first it needs the position x, y, and z. Argument could be, I should probably do this in a vector 3 just all together. I don't know, I'll have to revisit that. Then we need subset equals 0 and block type equals, we'll just say soil at the moment. Or shall I say grass? Grass looks nicer. There we go. So that'll go and generate the block. Now, if we just have a look at the generate block or gen block function, so we pass in the x, y, and z, done. And then it obviously uses those to generate a block there using the vertices and things, the mesh. This is subset. if you just leave it, by default it'll be -1, and that would just be the current subset. But I've got an idea that whenever we're doing some building, we'll just keep all the building attached to subset 0. And then if we need to know that later on, it will be easier than trying to refactor stuff. So gap, I think we'll just leave. So there's going to be a gap automatically above it. And then block type. Oh, we didn't need... Well, I'm going to pass in grass anyway, but I didn't need to because it's the default setting anyway. Building system. Where am I? Mine is in building system. I'm looking for mesh terrain. Oh, there's mesh terrain. Oh, I was already in there. Sorry, I was just in a different function, wasn't I? So same module. So subset 0, block type grass. Now, after we've done that, we need to then say this dot subsets 0, get hold of your model, and you need to generate, else you won't be able to see the difference. Right, let's go and see if we can build. Wow, my tea is cold. Okay, we haven't crashed the program. Yeah. Oh yeah, we need to make this highlighter better, don't we? Right, so if I right click, it worked first time. That's crazy. And if I right click him again, yes. Oh yeah, occasionally we get a random stone block. And then if we go high enough, we get snow. Okay. So I can just spam the button, and we're now building. Okay. Can we interact with these blocks? No. You'll notice that we're not stepping up. Although if I do one there, if I go forward, I am on top of this block now. And if I'm careful, no, I went down. Let me generate some more here. So I've got like a little bridge. Now, these are the same height. And if I go forward, I don't drop down, funnily enough. But if I go down here, I don't step up to the correct position. See, I'm still this height. And if I go here, I'm not stepping up. However, if I am at their height, I don't fall down. So, it's working correctly. So it is like we are generating a block there visually, and we're generating it correctly on the terrain dictionary because we do step on top of them. But we only step on top of them if we're coming from high up. So, the problem with that, and our error is working correctly, we're not able to build in the correct way. If we go back in the main module, where we're changing the subject position based on the subject, sorry, not the subset position, sorry, down here a bit more, where we're changing the subject height based on their position, X and Z. I've got a little loop, line 64, where we go from minus steps down, so you can set how many steps you're allowed to go up and down. So looking below us, if we find some terrain there, that's what this means. If we look at using our terrain dictionary, if we find some terrain 2 steps down, then our target height where we're going to move our subject is there, block found is true, and then we break. And then that means we just move to that position. So basically, when we've built on top of a block and we're standing there, we found a block underneath that we've built on top of, and we're just standing on that lower one. We're not then checking to see if there's another block above it, i.e. the one we just built, and standing on top of that. So we need to change this code. So before we set the target, we just want to say if, well actually we can repeat this, and this is a bit of a hack, because where you're repeating something, as a programmer, you're like, wait a minute, I just need to write this once and like create a function or something to do it more systematically. But at the moment, and it's probably good practice just to write in the pattern stuff concretely, and then you can concretely see what you can automate later on. Anyway, I want to say +1. So all I'm saying, is there another block on top of that? If there is, then again, I just want to copy this, like a little fractal. I want to say, actually, your target is one above what you just found, block found, break out of this loop here, and just go and move the subject. Now, what that means, you might have just thought is, what if I've done a tower? Because it will check that one, and it'll move me there, and then it'll check the next one. So now we're like mountain goats. We'll probably be able to climb up towers. It's a bug that's about to become a feature, I fear. So let's just run that now and see if we can climb up on stuff. Then, yeah, we've just got to check, can we mine stuff that we've built, delete it, and then rebuild it? That'll be the next test. So we can still build. Can we step up on it? No. What have I done wrong then? Let's build up a bit more. Oh, I was thinking, I'm getting too used to things working first time. This is much more like the proper experience. So we are stepping on it, but not these guys. Right. Let's just have a quick look at the code I just copied. If terrain td get xy plus I plus 1, so we are going up, equals t. I've got to set the target by 1. Again, very well done if you spotted that bug before I did. Let's go and see. Again, my little heart believes that this will work the first time, which is dangerous. So we've got our block, walking up to it. Yes! And we're stepping up and stepping down. That's very satisfying, because now our building is real. It's physical. And there we go. We can climb up towers, which is just a feature that we'll use. There we go. So we've got building in Minecraft. Brilliant. Can we delete stuff? We can mine and we can rebuild. That's brilliant. But when we try and mine stuff that we've built, we are spawning cave walls or tunnel walls. Or our old code is saying, hey, you're mining something, and it thinks we're underground, creating the illusion of going underground, but if we're overground, then there's a problem. So, we've already got a system that takes care of this, we just need to add it slightly. So, looking at my prepared code, in the building system module, I've also got a gap shell function, which is very short, and you probably recognize this if you followed the previous tutorial videos. In the mining, what we do is we iterate over all the positions, the 6 positions, like perpendicular from our mining site. So the block above, the block below, left, right, forward and backwards. And we like check to see if there's anything there. And if there is, we spawn a wall. Sorry, if there isn't anything, we spawn a wall, including a gap. If there's a gap, i.e. that's somewhere we've just mined, or it's the top of the terrain, that's like an invisible shell. If we hit the gap, then don't spawn anything there. So what we're basically creating is, around anything we've built, if there isn't anything around us, create a gap. And that means when the spawn function runs, it will hit a gap and it won't spawn those extra things above the terrain anymore, those extra blocks above the terrain anymore. So let's go and write that. I feel like I should kind of write it out properly. So gap shell, building system. So underneath check build, again, we'll have def, gap shell. It's creating like a shell of gaps around. And what did we need? We needed the terrain dictionary, presumably, and the building site, obviously. So underscore TD and underscore B site. There we go. Just so I know their parameters. Okay. So where did I get that stuff from? In the mining system is not the thing I was looking for. In the mesh terrain, yeah, here it is. When we generate walls, we look over all those 6 positions. So that's where I copy and pasted this and then adjusted it slightly. Or maybe didn't adjust it at all. So I'll just go to my prepare code and let's copy that. Back to my building system. There we go. So we've got a temporary variable just called what position. What position. And these are just vectors that point up, down, left, right, forward, backward. So on the Y position, the Y-axis, the X-axis, and the Z-axis. And they're just like unit vectors pointing that way. And we're storing them in a list so that we can iterate over them very easily. In fact, let's do that next. So for I in range 6, it should be WP length, really. In case I get very sophisticated one day. Well, 0 to 6. And then I'm saying position then equals whatever build site we've got plus one of these. So that moves us up, down, left, right as we go around that iteration. So P for position equals underscore B site. So that's the building site that we pass in plus WP, which is a vector, and we index the current one. And now what we're doing is checking if there's anything there. If there isn't anything there, make sure there's a gap. So building system prep. So if TD get floored that position X, Y, and Z, if there's nothing there, make sure there's a gap. So I don't feel bad copying and pasting that because it's very, very clear what it does. Just to save time. There we go. And I do need, so I do get punished a little for copy and pasting. P is the same name, but I used underscore TD in my present code. Right, so that's gap shell written, and it's in mesh terrain that I think I need to call it. So I generate a block, and then presumably I need to call I was in the wrong function there. I want to be in input. Here I am. So after I've generated the block, I can then say gap shell. This terrain dictionary, I also need to pass in the build site, don't I? So B site, B side, B site. And B site will exist because it's been generated from check build. There we go. So now, save that. Make sure I've saved the building system, else the changes won't be recognized. So let's just build some stuff quickly. We can walk on them, climb on them, and if we mine them, this time everything is working as expected. Lovely. So that's building complete. Well done. We've done it. So the final thing we need to do is just improve where we're looking in terms of our highlighting. So if I just go back to the main module and just comment out line 14, which is subject's cursor visible false. So by default it's true. If we just have a look, I think our highlighting is off. So there, I'm looking there, and we've got something highlighted to the left. Yeah, it's not very good. Okay, so I'll just quickly look at how I solved it. It's in the mining system module. So in the highlight here, what position equals position, so that'd be the subject's position plus the camera's view. I imagine we just have to lift it up slightly, something like that. Anyway, I worked it out in my prepared code. Let's go and have a look. Mining system. Here's my 3 asterisks. Yeah, what position equals position? Oh, so I just lift it up by the player's height. So that was the difference. We're kind of looking at things from the player's feet instead of their eye level. So this is kind of bad because I'm using like a magic number here. So I need to write a little comment. So I just copy that, take out my asterisks. So I know I've done that. No more asterisks. Let's make these single quotes. Thank you again, Mr. Less Right, for your help. Save my prepared code. Whoops. Where am I going? Mining system. So our position plus the player's height. So let's just write that in. Adjust for player's height. There we go. So when we refactor that later, we'll know what we're doing. Good. Right. Main, run this. How long has it been? 1 hour, 20 minutes. It's actually way off now. Although it feels like it's more aligned, but it's way too high. So I'm missing something. So maybe where I pass in a value, let's have a look. Mesh terrain. So probably be in mesh terrain's update. Yeah. Update. So this is my prepared one. Position cam this TD in my mesh terrain official one. Position cam this TD. That looks the same. Mining system, my one. So maybe I'm not adding 0.5 here. That's probably it. No, I am adding one. If I put that right there, let's see if we can spot the difference. Cam forward.I. Oh, what's this? +3. Ah, we don't need the +3. Oh, that's what I was doing. So before I hacked, it was my little hacky. I'm about 3 units away from my feet. So there we go. So that will be it. Did I put back the 0.5? Yeah, I didn't take that away, thankfully. Back to our main module. Run. I've got 11% battery life. Now it looks like we are pretty much dead on, or closer to dead on. You can't say pretty much dead on. Dead on means dead on. But there you go. So now we can mine where we want to mine and build where we're supposed to build. So next video, we need to sort out building with different materials and also kind of building maybe on the side of this block instead of always on the top. Right, thank you very much for watching. Leave any comments and you can download the code from the link in the description. Thank you very much. Happy New Year. Goodbye.